All right, this is, I believe, question 11 from 6.5, mutually exclusive events. So this question just reads, the 8 members of the debating club pose for a yearbook photograph. If they line up randomly, what is the probability that either Hania will be first in the row, or Aaron will be last? And then B, Hania will be first and Aaron will not be last. Okay, so we are going to do B first, and for questions like these where you have people lining up, or I don't know, like getting into a car or something like that, I recommend you draw this out. So for B, we're going to do exactly that. We're going to draw this out. We have 8 people, and they're all like lining up in a row. So we want Hania to be first, and oh, sorry. Before we start, sorry. Before we do any of this, I just want to remind everyone that we are going to consider this, the fundamental like equation of probability. So we're going to consider the outcomes of event A divided by the total number of outcomes. So with that being said, let's find the total number of outcomes, because it's going to be the same for both questions. And like our outcomes, so we're just considering the, I guess, total number of ways that we can have these 8 people line up. And in that case, we are going to have, for example, like we can put 8 people in the first position, and then we can put 7 people in the second position, and then 6, and then 5, and so on until we have 1. So our total number of outcomes is going to be 8 factorial. So we should remember this. Okay, cool. So for B, what we're going to do is we are going to put Hania first. So I'm going to write an H for Hania. I'm going to fix Hania first. Also, before I get too ahead of myself, I also want to define some events. So we're going to let H be Hania is first in the row, and then we're going to let A be Aaron. That's not how you spell Aaron. Aaron. Aaron is last in the row. So Aaron is right here. Okay. We're going to use these like 2 events for all of like both parts of the question. So this is why I'm defining them first. And basically, this question is asking us to find the probability of H being first, so like P of H, and Aaron, the complement of like A, because we want Hania to be first, so that's H, and then we don't want Aaron to be last, so that's going to be the complement of A, not A, basically. And we want both of these things to happen at the same time, so we're going to use an intersection and not a union here. All right, so getting back to the question, remember, we already know the total number of outcomes. We calculated that to be 8 factorial. What we want now is to find the number of ways where you can have like Hania be first and Aaron not be last. So we're going to put Aaron anywhere but the last position. He can go anywhere but the last position. But that being said, he can't go to the first position either. So now we need to think about how many positions like can Aaron be in. And the answer is 6. He can either be like second last, third last, fourth last, and so on. He can't be here and can't be here. So for Aaron, we're going to have 6. Like just for Aaron, we have 6 possibilities. And let's say I put him, I don't know, here. Just randomly here. That was an arbitrary decision. I could have put him here. I could have put him here. Doesn't really matter. I'm going to say I put him here. And in this case, how many ways can we arrange the other 5 people? Well, person, let's see, person 1 can be put here. And if you, person 1 we put here. And if you want to put person 1 here, there's 6 people that can be like put in this position. Because besides Hania and Aaron, there's 8 members. Sorry, besides Hania and Aaron, there's 6 members because there's 8 members in total. So we've already put Hania somewhere, we've already put Aaron somewhere, and now we have to worry about the 6 other people. For person 1, you can go here, and there's 6 people that you can put in like second position. For person 2, they could go here, and there's 5 people that you can put in the third position. And person 3 could go here, and there's 4 people that you can put, and so on and so on. So for person 4, person 5, and person 6, there's going to be 3 people that you can like put in this position, 2 people, and then 1 person. And it doesn't matter where you put Aaron, because if I take Aaron and I move him here, for example, like I move him here, then my person, then we can just move everybody like 1 spot down. So if I move him to the second position, if I move Aaron to the second position, then in the third position, I put like person 1 there, and that'll be 6, like there's 6 people. And then person 2 will have 5, and then so on and so on and so on. And again, it doesn't matter where I move Aaron. For example, if I want to move him here, then okay, we still have like 6 people that can go in the second position. We have 5 people that can go in the third position, and then we will just have 4 people that can go in the fourth position. So it doesn't matter where you move Aaron. The like number of, I guess, permutations for the other people remain the same. So for Aaron, we had 6 possibilities, and then for the other people, we have 6 factorial. And all of this needs to be divided by the total number of outcomes, which is 8 factorial here. Just put that over there. Okay, so that's going to be our probability. Give me 1 second. I just want to. Oh. Give me 1 second. I just want to group that on that. Okay. All right. That's much better. Okay. So this is going to be like our probability for this. Oops. For this H intersect a complement. And all we have to do now is just simplify this. So you either use a calculator or you do this by hand. But either way you're going to do this, you're going to get 3 over 28, and that will be your answer. Okay. So that is part B. Now we need to discuss A. So for A, I'm going to do it, I guess, at the, well, okay. I'm going to keep our result for B. So I'm going to move this to the side. And we're going to like kind of put a pin in this because we're going to need this for later. So I'm going to just group that and put that to the side. Okay, so for A, we need to consider a few like situations. So let me just clean this up a little bit, and we will be good. Just move that over here. Okay. All right. So A says we need to consider. Sorry, give me 1 second. I just got to change the letter. There we go. All right. So for A, we're looking for Hania being first in the row or Aaron being last. Okay, so if we write this using like a set notation like we did over here, we're looking for H union A. Looking for H union A. So we think about the possibilities for this situation, or like this, yeah, we think about the possibilities for this situation. So we're thinking about Hania being first or Aaron being last. So I see 3 ways that this could happen. 1, we have Hania be first and we have Aaron be last. We have Hania being first and Aaron not being last, This, by the way, is exactly what we calculated before in B. And finally, we have Hanya not being first and Aaron being last. So we need to calculate really just these two probabilities because we already have this one calculated for us. This was calculated in part like B. Okay. And if you're confused why like we're considering this when the question says either this or that, it's because, and I want to remind you, in math, when we say or, and this is just in math, but when we say like, for example, A or B, what we mean is A, B, or both. So if you have if you have A and B, that counts as A or B. This is how it works in math. This is how it works by definition. There's no great reason except mathematicians decided a long time ago that this is what or means. A, B, or both. And you just have to like remember this and accept it because this is how it works in math, unfortunately. Yeah, even though like in English, in like everyday language, when you say one or the other, you usually don't mean both. In math, you do mean both as well. Okay, so let's look at this one first. This is pretty simple because this is just, we want Hanya to be first. We want Aaron to be last. So we've already fixed their positions, and there's going to be like 6 other positions here where you can put other people. So in that case, sorry, give me 1 second. Okay, so yeah, there's like 6 other positions where you can put other people. So in that case, the number of like outcomes where you have Hanya first, Aaron last, this is just going to be equal to 6 factorial. And remember, we have that 8 factorial because this is the total number of outcomes. This is the total. This is the total number of outcomes here. So yeah, that is how that's going to go. And let me zoom out one more. Okay, so that's this first scenario. The second one we already know from part B. So this is just going to be 3 over 28. The third one is a little bit interesting because now we are putting Aaron last. That's what this means. But with Hanya, we don't want her to be first. Hanya is free to move anywhere she wants, except the first position. She can't be in the first position. Well, this is kind of like B, where we put Hanya first and we let Aaron just move wherever he wants. So because this is kind of the same thing as the first, as B, the probability of this is going to also be 3 over 28. Because it doesn't really matter who you fix. Like if I fix Aaron in the last position and let Hanya move around, that's the same thing as fixing Hanya in the first position and letting Aaron move around. It's going to give you the same result. So we have our 3 probabilities and we're adding them together. And the reason why we're adding them together, and remember, is because this is a mutually exclusive event compared to this and compared to this. You can't have Hanya and Aaron be first, and at the same time have Hanya be first and Aaron not be first, and also at the same time have Hanya not be first and Aaron first. Like either she's first or not, either he's first or not, and you can't have them both. Sorry, either she's first or not, either he's last or not. I meant last when I said this. Sorry, I meant last. And you can't have them be both first and not first, and last and not last. So this is why we're adding and not subtracting. It's because these 3 are mutually exclusive events. Okay, so you get your calculator, you add up these fractions, and you are going to get 13 over 56, I hope. If I did my math correctly, that should be your answer. Let me check this real quick. 13/56. Hopefully that's right. Okay, what the heck is going on? Where is this? Where is this in the answer? Oh, no, right section. Oh. Oh, okay. Sorry, your answer key gives these in fractions. So sorry, not fractions, but like as decimals. So just go and convert this into a decimal. That's approximately what it is. And then if you convert this into a decimal, this is approximately what it is. Okay, give me 1 second. I'm going to check just to make sure that this is the correct number. Because I wrote this in a fraction, and the answer key gives it as a decimal. So, yeah, that is the right decimal. Okay, so that's it.